Hi, I'm Sebastian from Beamex. I'll show you how to calibrate this short sanitary sensor. To do so, I will be also using a dedicated short reference sensor. And for the heat source, I will be using the MC6-T 150. This is a dry block that has a range of -30 to 150 degrees Celsius. And it has basically two functionalities. The dry block side, and then the multifunction communicator and calibrator. We have 3 RTD channels on board. This means that you can simultaneously measure 3 RTDs. There's also a lot of other features and functionalities, and to find out more, please visit our YouTube channel and watch the videos. When doing calibrations for short sanitary sensors, there's a few challenges that needs to be overcome. If we start looking at them through the reference sensor point of view. Here's one of my references. This model has a fairly long stem. And if I place it into my insert, I see that my immersion depth is about this much. Now if I compare it to my short sanitary sensor, the tips are on different levels. This means that they're not going to be able to measure correctly. There's too much uncertainty. I don't know what my result's really going to be. I need to have my reference on the same depth as the sensor that is being calibrated, and preferably as close to it as possible. So now when I place my short sensor on the insert, this one also has quite a big flange. It's covering all the other holes, so I cannot use this as a reference. To solve this, I need to use a short reference sensor with a flexible cable. So now I could use this, place it here, but the problem is I don't know what is the depth. To solve this, I have a special made insert with 2 holes, one for the instrument and one for the reference, and the holes go to the same depth. So now when I place the reference here, it stops where it should. There's also a groove so the cable can come on the side. And now when I place my instrument into the hole, I get a fully flushed surface. When I move this to my dry block, there's also grooves on top of the dry block, which helps me to get the cable out from the insert. So now when I place my sensor on the top, I get a fully flushed surface. This helps with the heat convection. I know I'm going to get good, consistent results with small uncertainties. Let's calibrate this short sensor. To do so, I will need to go to the Documenting Calibrator mode on the MC6-T, and I'll find it here in the up right corner. I can send my instrument to the calibrator either by generating it first in the calibration management software such as CMX or Logical, or I can manually make it here on the MC6-T. I have already sent it from CMX, so I can start my calibration. The information I see here is, for example, the position name, the device. I see my calibration points. In this case, I'm going to be doing a 3 points up. My range is going to be 30 to 50 degrees Celsius. And I also see how to do my connections. I've already placed my special insert here. I have my reference on place. I have my short sensor that I need to calibrate, and everything is connected. I'll hit start. And I'll now have started my calibration sequence. What you see here on the screen is, first of all, my set point. First point is going to be 30 degrees Celsius. And MC6-T is constantly calculating the error, comparing the reference to my sensor values and showing the value or the error, but also a graphical view. So what you will be seeing here is a green dot traveling between these 2 blue lines. If it's below or above, it's going to be a failed calibration. As long as it's inside, it's going to stay green and be a pass calibration. We'll now let it continue and take the first set point. This is going to document the results, meaning I don't have to use a pen or a paper to manually document, so I'm eliminating the human error in this phase. Now we are getting close to reaching the first set point of 30 degrees Celsius, and I can go and toggle to my graphical view, seeing my different input and output signals as temperature, and also the thinner line indicating my stability for each signal. When I get to a low enough point, the dry block will automatically record a set point, take the data, and give the instructions for the next set point. Now the MC6-T has reached its first set point. It has recorded it. We can see that it started heating, so we'll see that the temperature graph is going to go up, and also the stability is going to go up because the temperature is changing. And we are now going for the 40 Celsius set point. Now we're very close to reaching our second set point. In reality, a technician wouldn't need to be following this because this is all automated. They could be preparing for the next job, next calibration, or whatever they like to do. Now when I see my second set point, I can check, yeah, my stability is getting very close to being where it should be. So any second now, it's going to be able to record the second set point. The second set point is now reached. We see that it has drawn a green, very nice line. And it's now given my third and final set point, which is 50 degrees Celsius. We have now reached to the last set point for this calibration. I see that I have a passed result. I can also see my error, significance of it. I can put a note here. See my results in a graphical view and also in numerical view. And if I like, I could also put some environmental information here. I'm going to save it as found. I have calibrated, performed my tasks, and I would go back to the workshop to print out the certificate. I have already done that. I could either go completely paperless and keep my data within the software, or in this case, as I have done, printed out the certificate. I will then have this approved by my supervisor, have it signed, and the calibration is done and finished. In the certificate, I have all the necessary information needed for traceability. I have my results both in graphical and in numerical view. And then if I would write any notes while saving the calibration, this will be visible on the bottom side of the certificate. And this is how you calibrate a short sanitary sensor fully automatically with the help of the Beamex MC6-T 150. Thank you for watching and see you next time.